Hello guys, my name is Mr. TSEBE and today we'll be doing power method. So suppose that they gave us a problem like this. Complete 6 iterations to find dominant this dominant eigenvector and eigenvalue of that matrix. So this is what we start by doing. We're gonna let x0 to be 1 and 1. So we're gonna say x1 equals to a times x0, which is the same as original matrix 2 minus 12, 1 minus 5, 1 and 1. So 2 times 1 will be 2 plus 12 times this one will be minus 12. 1 times 1 will be 1 plus minus 5 times this minus 1 will be minus 5. So this can be simplified to be minus 10 and minus 4. So this can be approximated to be minus 4. So I'm taking this minus 4 out. So if I divide 10 by minus 4, I'm going to get 2,50. And if I divide this 4 by 4, I'm going to get 1. So this is the second iteration. So let's do the third. Sorry, I mean like this is the first iteration. Let's do the second iteration. So it will be x2 equals to a times x1. Our original matrix is 2 minus 12, 1 minus 5. So our second iteration was minus 10 and minus 4. Minus 10 and minus 4. Avoid taking this one. So this is the same as 2 times minus 10, which will be minus 20, and minus 12 times minus 4 plus 48. 1 times minus 10, this is minus 10. Minus 5 times this one, it's 20. And this is the same as 28 all over 10. And it can be approximated to be 10. So if I divide 28 by 10, I'm going to get 2,80. And if I divide 10 by 10, I'm going to get 1. So that was the second iteration. Let's check out the third. So x3 equals to a times x2. But our original matrix is 2 minus 12, 1 and minus 5. That is our original matrix. That is our original matrix. So what was the second iteration? Is 28 and 10. That means 2 times 28, 12 times 10, minus 12 times 10. 1 times 28 is just 28, minus 5 times this one is minus 5 times 10. And this can be simplified to be, if you can punch on your calculator, it will be minus 64 and minus 22. And this can be approximated to be minus 22, 2,90 recurring. This number is recurring, so that's why I'm putting a bar. And 22 over 22 is just 1. So this is my third iteration. So let's go to our fourth. So So our fourth iteration is the same as a times x3, but a is our original matrix, which is 2 minus 12, 1 and minus 5. What was our third iteration? Minus 64 and minus 22. This is our third iteration. So 2 times 64, 2 times minus 64 plus minus 12 times minus 22. 1 times minus 64, which is 64, minus 5 times 22 plus 5 times 22. As of negative and negative brings about positive. So if we simplify this using our calculators, so this is what we will be getting. That is what we will be getting. We'll be getting something like 136 all over 46. We'll be getting 136 over 46. And this can be approximated to be, it can be approximated to be 46. I'm taking 46 out. If I divide 136 by 46, I'm going to get 2,956521,739. And if I divide 46 by 46, I'm getting 1. So that was my fourth iteration. Let's go to our fifth. So it's x5 equals to a times x4. But a is our original matrix, which is 2 minus 12. 2 minus 12, 1 and minus 5. 1 and minus 5 multiplied by 136 and 46, which was our fourth iteration. And this is the same as 2 times 136 plus minus 12 times 46. 1 times 136, 1 times 136 plus minus 5 times 46. So if you punch this on your calculator, this is what you will get. If you punch that on your calculator, you are going to, because we said 2 times this one, and if you punch that on your calculator, you're going to get minus 280 all over minus 94. And this can be approximated to be minus 94. So if I divide minus 280 by minus 94, I'm going to get 2,97823 until. So if I divide 94 by 94, it's just 1. I'm just getting 1. So this was our fifth iteration. So let's check our last iteration, which is our sixth iteration. So x6 will be a times x5, and this is our original matrix, minus 12, 1 minus 5, and this one we are going to take minus 280 and minus 94. So by expanding this, it will be 2 times minus 280 plus minus 12 times minus 94. 1 times minus 280, which is minus 280, plus minus 5 times minus 94. So this is what we are getting. So if you can punch this on your calculator, you are going to get a number like this: 568 and 190. This is the number that you are going to get. So if I approximate this, I will take 190, and if I divide 568 by 190, I'm gonna get 2,98, 94, 736, blah blah blah. So if I divide 190 by 190, it's just 1. So this is my 6th iteration. This is my 6th iteration. So guess what, guys? Guess what, guys? This is my dominant eigenvector. This is my dominant eigenvector. Let me write it somewhere. So this is my dominant eigenvector, which is 190, 2,98, 94, 736, and 1. So this is my dominant eigenvector. So right now we want our eigenvalue. So how can we get our eigenvalue from this one? We are going to use what is called a Rayleigh coefficient, and is denoted by ax times x, x times x. But first, let's find ax. But we know that our A is this matrix: 2 minus 12, 1 minus 5. And this x, this little x, is this, what we found here. So I can just round it off and say 2,99 and 1. So I will do the same thing that I did. 2 times this one, 2 times 2 times 2,99 plus minus 12 times 1. 1 times 2,99 minus 5, like that. So this is what I'm gonna do. So if you punch on your calculator, you're going to get something like minus 6,02 and minus 2,01. So we found it. So we can come and substitute on our equation. So it will be minus 6,02 minus 2,01. So this is what we found. Multiplied by this one, 2,99 and 1. Because of x, our x is our eigenvector, and our eigenvector is this one. So even below, we are going to divide by 2,991, 2,991. So this is the same as minus 6 times this one times this one. So it will be minus 6,02 times 2,99 plus minus 2,1 times this one, minus 2,01 times 1, all over 2,99 times 2,99 plus 1 times 1, 1 times 1. Let me make sure that you can see. Plus 1 times 1, 1 times 1. So 2,99 times 2,99. So our dominant eigenvector, if you use your calculator, will be the same as minus 2,01. Minus 2,01. So this is our eigenvalue, our dominant eigenvalue with its respective to with respect to its dominant eigenvector. So ladies and gentlemen, this brings me to the end of our session. I hope you enjoyed it, and if you enjoyed it, please subscribe and share with your friends. Thank you.